In this example, we're going to see some variables thrown into our determinants. So for this problem, we're going to be determining the value or values of k that are going to make the following 3 by 3 matrix a singular matrix. So that is 0, k, 1, k, 1, k, 1, k, 0. So with those things in mind, a matrix is singular if it is not invertible, and it's not invertible is equivalent to the determinant of A being equal to 0. So what we're going to do is set up the determinant of A being equal to 0, and we'll see if we can solve that for k. So again, 0, k, 1, k, 1, k, 1, k, 0. That's going to be equal to 0. Now as far as actually determining what this determinant is equal to, determining the determinant, I am going to do a cofactor expansion across the first row. So for this cofactor expansion, we will be multiplying the 1, 1 entry times the 1, 1 cofactor plus the 1, 2 entry times the 1, 2 cofactor. 1, 2 cofactor will contribute a negative. Getting rid of the first row, second column, that'll be k, k, 1, 0. And for the 1, 3 entry, that'll be plus 1 times the 1, 3 minor. That'll be k, 1, 1, k. And again, all of this is supposed to be equal to 0. Continuing to expand as much as possible, the first term here, because the coefficient of 0, that's going to go away. We'll see negative k times 0 minus k times 1 plus 1 times k minus 1 times 1. Continuing to simplify as much as possible, this term is going to go away since it has a 0 in it. We'll have negative k times negative k. That'll be k squared plus the other term is going to be a k squared minus 1. That'll be equal to 0, giving us the following equation. 2k squared minus 1 is equal to 0. I'm going to add 1 to both sides, divide 2 on both sides. We'll get k squared is equal to 1/2. Telling us the two possible values for k, that's going to be plus or minus the square root of 1/2. So I guess we could simplify that to plus or minus 1 over the square root of 2. Or if the algebra teacher is resounding in your head right now, rationalize the denominator. We can call that plus or minus root 2 over 2. Reminds me of some trigonometry, but that's probably something for another day.